to our channel. In this channel, we will be mainly focusing on providing solutions to NCERT exercise problems for classes 10th, 11th and 12th. And also will be providing step-by-step solutions to all your exercise problems from the exam point of view. And at the end of each chapter, we will be discussing previously asked board exam questions of the respective chapters. So today, we are going to start with the first chapter of class 10th, that is real numbers. So before moving into the chapter, we should know what are the natural numbers, whole numbers, rational numbers, irrational numbers, integers, etc. So first I'll be discussing about the natural numbers. Natural numbers. Natural numbers is the part of a number system. It is represented by the letter N. Natural numbers are those numbers which consist of positive integers from 1 till infinity. It does not include 0. 0 is not included in natural numbers and they can be represented in a number line. If this is the number line, there is 0, 1, 2, 3, etc. And here it is -1, -2, -3, etc. till infinity. So all the positive integers starting from 1 till infinity is called the natural numbers. Now, second one is whole numbers. Whole numbers is also part of the number system and it includes all positive integers starting from 0 till infinity. So in natural numbers it starts from 1 till infinity and in whole numbers it starts from 0 till infinity. And these are called counting numbers including 0, and natural numbers are also called counting numbers. Whole numbers are called counting numbers starting from 0. So this whole numbers can also be represented on a number line, etc. Here it is -1, -2, -3, etc. So all the positive integers starting from 0 till infinity constitute the whole numbers, and whole numbers is represented by the letter W. The smallest whole number is 0. 0 is the smallest whole number. We can quote, natural numbers are whole numbers, while whole numbers are not natural numbers. Natural numbers are whole numbers, but whole numbers are not natural numbers. So natural numbers are whole numbers, but whole numbers are not natural numbers, because natural numbers consist of all positive integers starting from 1 till infinity, and whole numbers consist of all positive integers starting from 0 till infinity. So all the natural numbers are whole numbers, because see, all these comes in whole numbers, but whole numbers we cannot say it has natural numbers, because in whole number there is an extra 0 which is not present in the natural number. So all natural numbers are whole numbers, but whole numbers are not natural numbers. Okay, now next we'll be discussing about integers. So what are integers? Integers are sets of numbers comprising of 0, positive integers, positive numbers as well as negative numbers. So it includes all whole numbers and negative numbers. Okay, we can say integers constitutes 0, positive numbers and negative numbers. So we can say this positive and 0 can be called whole numbers. So integers are all whole numbers along with negative numbers. So integers are those with no decimal or fractional part, and it includes negative and positive numbers including 0. So we can say examples as 0, -1, -2, 1, 3, 5, etc. all comes under integers. So integers cannot have decimal or fractional part. It includes 0, all positive numbers and negative numbers. What is a positive number? A positive number means a number is positive if it is greater than 0. Positive number should always be greater than 0, and negative numbers are those numbers which are less than 0. And 0 is defined as neither positive nor a negative number. It is called as a whole number. Okay, so 0, it can be called a whole number. It doesn't fall under a positive number or as a negative number. So it is neither a positive number nor negative number. It is called as a whole number. So for example, as we can write a set of integers as an integer is represented by the letter z. So 0, -1, -3, 1, 2, etc. All this is a set of integers. Next one is rational numbers. So what are rational numbers? Rational numbers are those that can be represented in the form p by q, where p and q are integers, and q is not equal to 0. For example, 3 by 5, where 3 and 5 are integers and 5, that is the denominator, is not equivalent to 0. And the rational numbers can be recurring. So here if we check after the decimal point, you can see the number is getting repeated. So it is called recurring. So rational numbers can be recurring. For example, 0.777 or say 8888. Here you can see after the decimal point the digit 8 is getting repeated. So rational numbers can be recurring. If we check, like see for example root of 81. Root of 81 is equivalent to 9, which can be represented in the form p by q or in the form fractional form. 9 by 1, where 9 and 1 are integers and this denominator is not equivalent to 0. So we can say root of 81 is a rational number. Now next we will be moving on to what is an irrational number. So irrational numbers are those that cannot be represented in the simple fraction form, or those numbers that are not rational. For example, root 2 is an irrational number because it cannot be represented in a simple fraction form and the value is 1.41414, etc. So here we can see that the values are non-recurring and non-terminating. It is non-recurring and non-terminating. So irrational numbers can be written in decimal form and it can have endless non-repeating digits after the decimal point. So we can see the irrational number can be written in the decimal form and it can have endless non-repeating digits after the decimal point. See, after the decimal point it is 4 1, then again 4 1, 4 1, etc., etc. So it is not, the digits are not repeating. While rational numbers, you can see after the decimal points the number is getting repeated, so it is recurring. Here it is non-recurring and it's not terminating, so it is non-recurring and non-terminating. For example, if you check, root 8 is equivalent to 2.828, etc. So here after the decimal point we can see that digits are not repeating, it's non-recurring. Now last but not the least, we are going to know what is real numbers. That is, what are real numbers? Real numbers can have positive integers, it can have negative integers, it can be irrational, it can be rational, it can be rational numbers. So all these are examples of real numbers. For example, it can be -1 or root 2 or 0 or 0.75, etc. So we can say real numbers can be positive integers, negative integers, rational numbers or irrational numbers. So real numbers is actually a combination of rational numbers and irrational numbers. Or real numbers, we can say it constitute the union of rational numbers, if this is a rational number and this is irrational number. It is a union of rational as well as irrational number. So real numbers can be expressed in a number line. So any real number, be it any real number, they can be expressed in a number line. For example, real number means it can be a rational number or a irrational number, so anything. So here 0.2, so see this, so it is a real number, right? For example, 0 minus 1, be it root 2 or 0.75. See, 0 can be represented, -1 can be represented. Root 2 is 1.414, so it is approximately somewhere over here. 0.75 is somewhere over here. So all these real numbers can be expressed on a number line. And real numbers, it can be represented as a chart known as the real number chart. So real numbers are actually, it's the union of irrational numbers and rational numbers. Rational number is represented by the letter Q. So rational number can be integers as well as non-integer rational number. Integers is represented by the letter Z. Integers can again be classified as whole numbers as well as negative numbers. Whole numbers can again be classified as natural numbers and 0. So this chart is called the real number chart. So I hope everyone has got an idea about real numbers. So now moving into the chapter, the first theorem that we come across is the Euclid's division lemma theorem. So this theorem states that given positive integers a and b, there exists a unique integer q and r satisfying the equation a is equal to bq plus r, where r's value is in between 0 and it should be in between 0 and the other value should be less than b. So for example, if a is equal to 8, b is equal to 3, then r's value should lie between 0 to less than 3, that is 0 to 2. So 0, 1 and 2. So this is what Euclid's division lemma states. So the theorem states that there are two given positive integers a and b, then there exists a unique integer q and r satisfying the following equation. So here this equation a is equal to bq plus r is similar to dividend is equal to divisor into quotient plus remainder. So see, if a is equal to 40, b is equal to 5, then 40 is equal to 5 into 8 plus 0. So here you can see, like for example, see 40 divided by 5, 8 5s are 40 and 0. So here 5 is the divisor, 8 is the quotient and 0 is the remainder and 40 is the dividend. So a lemma means it's a proven statement that is used for proving another statement. That is what is known as a lemma. Now what is an algorithm? So now next we'll be learning about Euclid's division algorithm. Euclid's division algorithm is a technique that is used to compute the highest common factor when two positive integers are given, that is HCF of two positive integers can be found using the Euclid's division algorithm. So what is algorithms? What do you mean by algorithm? Algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. So to obtain the HCF of two positive integers, say C and D, where C should be greater than D, then we should follow the steps below. Okay, so we are given like two integers C and D, and we have to find the HCF of the C and D. And if C is greater than D, if C is a positive integer and D is a positive integer and C's value is greater than D, and if we have to find the HCF of these two numbers, then we can follow these three steps. The first step is apply Euclid's division lemma to C and D, so we find the whole numbers Q and R. So the lemma equation is C is equal to D into Q plus R, where Q is quotient, R is the remainder, D will be the divisor, this will be the dividend. So here if we are given two positive integers C and D, and if value of C is greater than the value of D, then we can apply the Euclid's division lemma to C and D, and we can find the whole numbers Q and R such that C is equal to DQ plus R, where R's value lies in between 0 and value less than D. And if R equal to 0, that means if remainder is 0, then we can say this D is the HCF of C and D. If R is equal to 0, then we can say D is the HCF of C and D. D is the HCF of C and D. And if R is not equal to 0, then we'll have to apply the division lemma to D and R. That is, previously the first equation was C is equal to DQ plus R. And if R is not equivalent to 0, then we'll be applying the division lemma to D and R. That is, it becomes D is equal to RQ plus R1. Okay, and then again we'll continue the process till our remainder becomes 0. The divisor at this stage will be the required HCF. Till the R becomes 0, we continue this division lemma, and once the R becomes 0, then our divisor, whatever value is the divisor, it becomes the required HCF. You will get more idea on this once we start, or once I explain a example. So I'll be explaining this a bit more by using an example, so you'll get an idea.